a WikiVidi Documentaries production. Don't forget to like and subscribe. Enjoy. Sustainable energy. Sustainable energy is energy that is consumed at insignificant rates compared to its supply and with manageable collateral effects, especially environmental effects. Another common definition of sustainable energy is an energy system that serves the needs of the present without compromising the ability of future generations to meet their needs. Renewable energy is not a synonym of sustainable energy. While renewable energy is defined as one that is naturally replenished on a human timescale, sustainable energy is one the use of which will not compromise the system in which it is adopted to the point of not being fit to provide needs in the future. The organizing principle for sustainability is sustainable development, which includes the four interconnected domains: ecology, economics, politics and culture. Sustainability science is the study of sustainable development and environmental science. Technologies promote sustainable energy including renewable energy sources, such as hydroelectricity, solar energy, wind energy, wave power, geothermal energy, bioenergy, tidal power, and also technologies designed to improve energy efficiency. Costs have decreased immensely throughout the years, and continue to fall. Increasingly, effective government policies support investor confidence, and these markets are expanding. Considerable progress is being made in the energy transition from fossil fuels to ecologically sustainable systems, to the point where many studies support 100% renewable energy. Definitions: energy efficiency and renewable energy are said to be the twin pillars of sustainable energy. In the broader context of sustainable development, there are three pillars: ecology, economy and society. Some ways in which sustainable energy has been defined are: this sets sustainable energy apart from other renewable energy terminology such as alternative energy by focusing on the ability of an energy source to continue providing energy. Sustainable energy can produce some pollution of the environment, as long as it is not sufficient to prohibit heavy use of the source for an indefinite amount of time. Sustainable energy is also distinct from low-carbon energy, which is sustainable only in the sense that it does not add to the CO2 in the atmosphere. Green energy is energy that can be extracted, generated, and/or consumed without any significant negative impact to the environment. The planet has a natural capability to recover, which means pollution that does not go beyond that capability can still be termed green. Green power is a subset of renewable energy and represents those renewable energy resources and technologies that provide the highest environmental benefit. The U.S. Environmental Protection Agency defines green power as electricity produced from solar, wind, geothermal, biogas, biomass, and low-impact small hydroelectric sources. Customers often buy green power for avoided environmental impacts and its greenhouse gas reduction benefits. Renewable energy technologies. Renewable energy technologies are essential contributors to sustainable energy as they generally contribute to world energy security, reducing dependence on fossil fuel resources, and providing opportunities for mitigating greenhouse gases. The International Energy Agency states that first- and second-generation technologies have entered the markets, and third-generation technologies heavily depend on long-term research and development commitments, where the public sector has a role to play. Regarding energy used by vehicles, a comprehensive 2008 cost-benefit analysis review was conducted of sustainable energy sources and usage combinations in the context of global warming and other dominating issues. It ranked wind power generation combined with battery electric vehicles and hydrogen fuel cell vehicles as the most efficient. Wind was followed by concentrated solar power, geothermal power, tidal power, photovoltaic, wave power, hydropower, coal capture and storage, nuclear energy and biofuel energy sources. It states, in sum, use of wind, SPE, geothermal, tidal, PV, wave, and hydro to provide electricity for BEVs and HFCVs and, by extension, electricity for the residential, industrial, and commercial sectors, will result in the most benefit among the options considered. The combination of these technologies should be advanced as a solution to global warming, air pollution, and energy security. Coal CCs and nuclear offer less benefit, thus represent an opportunity cost loss, and the biofuel options provide no certain benefit and the greatest negative impacts. First-generation technologies. Among sources of renewable energy, hydroelectric plants have the advantages of being long-lived. Many existing plants have operated for more than 100 years. Also, hydroelectric plants are clean and have few emissions. Criticisms directed at large-scale hydroelectric plants include dislocation of people living where the reservoirs are planned, and release of significant amounts of carbon dioxide during construction and flooding of the reservoir. However, it has been found that high emissions are associated only with shallow reservoirs in warm locales, and recent innovations in hydropower turbine technology are enabling efficient development of low-impact run-of-the-river hydroelectricity projects. Generally speaking, hydroelectric plants produce much lower life cycle emissions than other types of generation. Hydroelectric power, which underwent extensive development during growth of electrification in the 19th and 20th centuries, is experiencing resurgence of development in the 21st century. The areas of greatest hydroelectric growth are the booming economies of Asia. China is the development leader. However, other Asian nations are installing hydropower at a rapid pace. This growth is driven by much increased energy costs, especially for imported energy, and widespread desires for more domestically produced, clean, renewable, and economical generation. Geothermal power plants can operate 24 hours per day, providing base load capacity, and the world potential capacity for geothermal power generation is estimated at 85 gigawatts over the next 30 years. However, geothermal power is accessible only in limited areas of the world, including the United States, Central America, East Africa, Iceland, Indonesia, and the Philippines. The costs of geothermal energy have dropped substantially from the systems built in the 1970s. Geothermal heat generation can be competitive in many countries producing geothermal power, or in other regions where the resource is of a lower temperature. Enhanced geothermal system technology does not require natural convective hydrothermal resources, so it can be used in areas that were previously unsuitable for geothermal power, if the resource is very large. EGS is currently under research at the U.S. Department of Energy. Biomass briquettes are increasingly being used in the developing world as an alternative to charcoal. The technique involves the conversion of almost any plant matter into compressed briquettes that typically have about 70% the calorific value of charcoal. There are relatively few examples of large-scale briquette production. One exception is in North Kivu, in Eastern Democratic Republic of Congo, where forest clearance for charcoal production is considered to be the biggest threat to mountain gorilla habitat. The staff of Virunga National Park have successfully trained and equipped over 3,500 people to produce biomass briquettes, thereby replacing charcoal produced illegally inside the national park, and creating significant employment for people living in extreme poverty in conflict-affected areas. In Europe in the 19th century, there were about 200,000 windmills, slightly more than the modern wind turbines of the 21st century. They were mainly used to grind grain and to pump water. The age of coal-powered steam engines replaced this early use of wind power. Second-generation technologies. Solar heating systems are a well-known second-generation technology and generally consist of solar thermal collectors, a fluid system to move the heat from the collector to its point of usage, and a reservoir or tank for heat storage and subsequent use. The systems may be used to heat domestic hot water, swimming pool water, or for space heating. The heat can also be used for industrial applications or as an energy input for other uses such as cooling equipment. In many climates, a solar heating system can provide a very high percentage of domestic hot water energy. Energy received from the sun by the Earth is that of electromagnetic radiation. Light ranges of visible, infrared, ultraviolet, X-rays, and radio waves received by the Earth through solar energy. The highest power of radiation comes from visible light. Solar power is complicated due to changes in seasons and from day to night. Cloud cover can also add to complications of solar energy, and not all radiation from the sun reaches Earth, because it is absorbed and dispersed due to clouds and gases within the Earth's atmospheres. In the 1980s and early 1990s, most photovoltaic modules provided remote area power supply, but from around 1995, Industry efforts have focused increasingly on developing building integrated photovoltaics and power plants for grid-connected applications. Currently, the largest photovoltaic power plant in North America is the Nellis Solar Power Plant. There is a proposal to build a solar power station in Victoria, Australia, which would be the world's largest PV power station, at 154 megawatts. Other large photovoltaic power stations include the Girasol Solar Power Plant and the Waldpolen Solar Park. Some of the second-generation renewables, such as wind power, have high potential and have already realized relatively low production costs. At the end of 2008, worldwide wind farm capacity was 120,791 megawatts, representing an increase of 28.8% during the year, and wind power produced some 1.3% of global electricity consumption. Wind power accounts for approximately 20% of electricity use in Denmark, 9% in Spain, and 7% in Germany. However, it may be difficult to site wind turbines in some areas for aesthetic or environmental reasons. And it may be difficult to integrate wind power into electricity grids in some cases. Solar thermal power stations have been successfully operating in California commercially since the late 1980s, including the largest solar power plant of any kind, the 350 megawatts solar energy generating systems. Nevada Solar One is another 64 megawatts plant which has recently opened. Other parabolic trough power plants being proposed are 250 megawatts plants in Spain, and a 100 megawatts plant in Israel. Solar and wind are intermittent energy sources that supply electricity 10–40% of the time. To compensate for this characteristic, it is common to pair their production with already existing hydroelectricity or natural gas generation. In regions where this isn't available, wind and solar can be paired with significantly more expensive pumped storage hydroelectricity. Brazil has one of the largest renewable energy programs in the world, involving production of ethanol fuel from sugarcane, and ethanol now provides 18% of the country's automotive fuel. As a result of this, together with the exploitation of domestic deepwater oil sources, Brazil, which years ago had to import a large share of the petroleum needed for domestic consumption, recently reached complete self-sufficiency in oil. Most cars on the road today in the US can run on blends of up to 10% ethanol, and motor vehicle manufacturers already produce vehicles designed to run on much higher ethanol blends. Ford, Daimler Chrysler, and GM are among the automobile companies that sell flexible fuel cars, trucks, and minivans that can use gasoline and ethanol blends ranging from pure gasoline up to 85% ethanol. By mid-2006, there were approximately 6 million E85 compatible vehicles on US roads. Brought to you by WikiVidi Documentaries. Would you like to know more?